This is Algebra 2, Lesson 8-2, the reciprocal function. A reciprocal function is any function that contains a fraction with the independent variable in the denominator. For example, y equals 1 divided by 3x plus 1, or f of x equals 1 over x minus 2, or g of x equals 5 over 2x minus 8. The independent variable, as you can see, is in the denominator, so it's called a reciprocal function. A branch is each part of the reciprocal function. When you work with the reciprocal function, the general form of the reciprocal function family, remember we always have the general form of an equation, and we've always been using h and k. This will stay the same in this particular instance as well. We will continue to use h and k. The general form of the member of the reciprocal function family is y equals a over x minus h plus k, where obviously x cannot equal h because if it did, you'd have a 0 in the denominator, which is not fine. The inverse variation functions are y equals a over x. They are stretches, shrinks, and reflections of the parent reciprocal function, depending on the value of a. Okay. Over here on the right, I have a graph of the function y equals 1 over x. That's the parent function. As you'll see, there are two branches. One branch in quadrant 1 over here, and one branch in quadrant 3 over here. Okay. All reciprocal functions will have two branches. Okay. Two or more branches, I should say. Okay. The graph of a parent reciprocal function that's the very basic parent reciprocal function. That's the reciprocal function we will refer back to many, many, many times within this chapter in this lesson. So, if I need to graph a reciprocal function, I'm going to graph y equals 12 over x, and obviously x cannot equal 0 because you can't divide by 0. We're going to identify the x and y intercepts and the asymptotes of the graph. We'll also state the domain of the range of this function. Okay, so the first thing I'm going to do is I'll make a table of values which includes positive and negative values of x. And obviously I can't include 0 because division by 0 is undefined, so it's not one of the numbers I'm going to include. And I'm going to have a lot of numbers here, just to show you that you can get the general idea of what the graph's going to look like if you plot more numbers. Okay? So I'm going to make an x and y table. It's going to be a very large x and y table. I probably should do it horizontally instead of vertically, but I'm just going to do a couple of them vertically. It just makes it easier. Okay? I'm going to start with values of multiples of 12, because I know that makes it easier. So if I make x negative 24, 12 divided by negative 24 is negative 1/2. Then I'm going to go a little smaller. I go negative 12. 12 divided by negative 12 is negative 1. Okay. Then I'm going to go down to negative 8. I'm just going to do multiples that are easy to divide by 12. 12 divided by negative 8 is negative 1/2. Then I'll go to negative 4. 12 divided by negative 4 is negative 3. And then I'm going to go to negative 3. 12 divided by negative 3 is negative 4. If I divide by negative 2, 12 divided by negative 2 is negative 6. If I divide by negative 1, 12 divided by negative 1 is negative 12. Okay, I can't divide by 0, so now I'm going to start going up. Okay? If I do 12 divided by 1, I get 12. If I get 12 divided by 2, I get 6. 12 divided by 3 is going to give me 4. Okay, 12 divided by 6 is going to give me 2. 12 divided by 8 is going to give me 1.5. And 12 divided by 12 is going to give me 1. I'm not going to go 12 divided by 4 because my graph's not going to either. So I have my plots, my points. So now I can plot my points. Okay. So I'm going to graph my points on my x and y axis here. I obviously can't go to 24 unless I graph by something other than 1s. I really can't even go to negative 12, but I can go to negative 8. So I'm going to do x negative 8, y is negative 1.5. 1, 2, 3, 4, 5, 6, 7, 8, 1.5. There. There. If x is negative 4, 1, 2, 3, 4, 1, 2, 3, it's here. If x is negative 3, it's 4. If x is negative 2, it's 6. 6 is there. If x is negative 1, we're down to 12. So this branch will look something like this. Okay. The other branch, 1, 12, I'm not going to graph 2, 6, I'm going to graph 1, 2, 1, 2, 3, 4, 5, 6 is here. Then I'm going to do 3, 4, 4, 3, 6, 2, 8, 1.5. So this branch in this quadrant is going to look like this. And this is the graph of y equals 1 over x. Now, if we look at this graph, we can clearly see the asymptotes. Okay? Because I can look at that and see the intercepts from easily. I know that since x cannot equal 0, because that was defined that way, since x cannot equal 0, there's no y-intercept. Okay, so I've graphed my points. I'm going to look at my intercepts now. Okay, since x cannot equal 0, there is no y-intercept. Okay. And the numerator can never be 0. Okay. Since the numerator can never be 0, there's no x-intercept. Okay, numerator can't. The numerator can never be 0, so y is never 0. Okay. Y can never be 0. So there's no x-intercept. So there's no x-intercept, there's no y-intercept. If we look at the graph, we can clearly see our vertical and horizontal asymptotes. Horizontally, left and right, you'll notice that your graph is never going to cross your x-axis. So your horizontal asymptote is your x-axis. And the line for the x-axis is the same as the y equals 0 line, just know that. X-axis or the y equals 0 is your horizontal asymptote. Your y-axis is your vertical asymptote. Okay, remember your vertical asymptote is your x equals 0. That's what your y-axis is. Okay, last but not least, let's look at my domain and range. Okay? And I look, what can I put in for x? I can put in any number I want except for 0, because I can't have a 0 in my denominator. So my domain is going to be x such that x cannot equal 0. All numbers except x can't equal 0. My range is what can I get out of it? Okay, well, we know that y can't ever equal 0 because it approaches the y-axis but never touches the y-axis. So I know that y can't equal 0 either, so the range is going to be all values of y such that y cannot equal 0. And there we have graphed our graph, we figured out our asymptotes, and we figured out our domain and range. Okay, and if you'll notice, this is in quadrant 1 and 3. Okay? The branches of the parent function of 1 over x are in quadrant 1 and 3. Stretches and compressions of the parent function will remain in those same quadrants. Reflections will make them move to quadrants 2 and 4. And just move to the opposite quadrants. You can translate any reciprocal function horizontally or vertically, just like we've done all the other functions we've dealt with this year. Okay? So, if I'm going to look at something, okay, if my parent function is y equals 1 over x and x cannot equal 0, stretches and compressions occur based on the value of a. Okay? If the absolute value of a is greater than 1, it's going to stretch it. That's why it's in blue. If the absolute value of a is between 0 and 1, in other words, if a is a fraction, okay, 1/5 times x, okay, or 0.2 over x, then it's going to shrink it. If a is less than 0, it's going to reflect it across the x-axis. Okay, so it's going to go from quadrant 1 down to quadrant 4. Translations occur based on the value of h and k. And it's just like it used to. Okay? Just like before, h does horizontally, k does vertically. Okay? So if it shifts it, if you have h down here, that's going to do a horizontal shift. If it's minus h, it's going to go left. So it's going to go right. If it's positive h, it's going to go left. Okay? If it shifts it horizontally, and it shifts it vertically. If it shifts it horizontally h units, then it has a vertical asymptote at x equals h. So if this said x minus 4, it would have a vertical asymptote at x equals 4. If it shifts it vertically, that's your k value, that's what's outside of the fraction. It's going to shift it vertically, k units, okay, and that's going to be your horizontal asymptote. Combined, it looks just like this. And remember, we've done things with a's and h's and k's all year long, so you should be able to get used to this. And obviously, h can never equal x can never equal h because you have division by 0. So, if you're you're translating a reciprocal function, the good first step is to draw your asymptotes, because that helps you determine where your graph is going to be. It helps you with your shape. So if I have the graph of y equals 1 over x minus 4 plus 6, the first thing I'm going to do is do my asymptotes. Okay? I'm going to identify my h and k values here. H equals 4 and k equals 6, because this would be h and this would be k. Okay, so h equals 4 and k equals 6, which means I know my horizontal asymptote and I know my vertical asymptote. My vertical asymptote, okay, and remember, the vertical asymptote is x equals h. So in this case, my vertical asymptote is going to be x equals 4. My horizontal asymptote, what is it changing up and down, is y equals whatever k is, so y equals 6. So I'm going to draw those asymptotes right now in my graph, and I always draw my asymptotes with a dashed line. So my vertical asymptote is at x equals 4, so 1, 2, 3, 4, so I'm going to have a dashed line at x equals 4. And I'm going to vertical asymptote at y equals 8.
Hi teachers, there is breakfast in room 6.
Okay, so I have my vertical asymptote at y equals 6, so 1, 2, 3, 4, 5, 6. So there's my vertical asymptote right there. And my horizontal and vertical asymptotes are drawn. So now I just need to translate the graph of 1 over x. Really all I need is I need one point. I need the point that's probably going to be closest to the asymptotes, so that I can kind of draw the general short shape of my branches, because I don't have a stretching or a shrinking. So I don't have to worry, because there's no a value. A value is 1, so that's the basic parent function here. So I just need to translate my graph. So if I have y equals 1 over x, if I have a little table of values, I'm just going to put in when x is 1, y is 1, and when x is negative 1, y is negative 1. Okay? So if I plotted those 2 points normally, that would help me determine my branches. But now I need to translate them. That's the points I would plot using the parent function, but we know we need to translate this graph 4 units. Translate this 4 units to the right and 6 units up. So I'm going to take the point 1, 1, and I'm going to transfer it 4 units to the right. 1, 2, 3, 4, 6 units up. 1, 2, 4, 5, 6. I'm just going to go there. Then I'm going to take the point negative 1, negative 1. I'm going to translate that 4 units to the right and 6 units up, and it's going to be right here. You might say, how does that help you? Basically, that's the closest point that I'm going to have in my graph. I just need to draw my branches this way. It's just a sketch. It doesn't have to be perfect. So this is now y equals 1 over x minus 4 plus 6. And that's the sketch of the graph. And all we did was translate the parent function to do that. It's actually not as complicated as people would think it would be. Now, let's say if we know the asymptotes of our graph of a reciprocal function and the value of a, we can write the equation of a function. Okay? Let's just take a look at this graph right here. This graph is a function of the translation of the graph y equals 2 over x. Okay? So it's been stretched a little bit. Okay? Because a is 2. And when a is greater than 1, it stretches by a factor of 2. Okay? So we are going to figure out the function, the equation for this. Notice they didn't label it. We need to label it. They need to know, what is this graph? So we're going to label this. So the first thing we're going to do is we're going to identify our asymptotes. Okay? So we're going to figure out what our h and k is. Okay? So the first thing I'm going to do is I'm going to look at my graph and say, what are these asymptotes? Let's look at the vertical asymptote first. That would be this line right here. The vertical asymptote. We're counting by, on the horizontal axis, notice it goes 0, then it goes 4, and then it goes 8, but it skips. So it's 0, 2, 4, 6, 8. This is not at the 2. It's halfway between the 0 and the 2, so it's going to be x equals 1. Okay? So we now know from this x, this is the point of x equals 1. Okay? So I know with that asymptote that I know that x equals 1 is my vertical asymptote. If I look at my horizontal asymptote, that's the guy going left and right. Okay? If I look down here, this is 0 right here. This is -8 right here, so we're going to go 2, 4, 6, 8. We're still counting by 2s. So if we count, that's going down to -4. So I know y equals -4 is my other asymptote. That's this one here, y equals -4. So my h value is 1, and my k value is -4. So now that I know what h and k are, we can do those in the general form of the equation. If you remember, the general form of the equation is y equals a over x minus h plus k. So let's substitute in what I know. Y equals, my a is 2, isn't it? Because way back here, that's what we had in our equation. So y equals 2. So I have 2 over x minus h, which is 1, plus k, plus a -4. I could leave it like that, but it's a little bit better to simplify it all the way to cleaned up form. So y equals 2 over x minus 1 minus 4. And that's the equation of this graph. So now I can label that on the equation because I have it. Okay, so it's not hard to label an equation as long as you know what the a is. If you don't know what the a is, that's going to take a little while, and they're not going to do that to you, so don't worry about that. All right, using a reciprocal function. The junior class is renting a laser tag facility with a capacity of 325 people. You have a very large junior class. It's not here. The cost for the facility is $1,200. The party must have 13 adult chaperones. If every student who attends shares the facility cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of this function, and how many students must attend to make the cost per student no more than $7.50? So let's figure this out a little bit. Okay, first of all, we know, or we should know, that the cost per student is going to be the $1,200 divided by the number of students. And notice that's not chaperones, just number of students. And the number of students who attend, and your number of students, okay, the greatest number of students who can attend can be the capacity minus the chaperones. Okay, so in this case, 325 minus 13. So that's the greatest number of students that can attend. This is 312. So let's see if we can write this into a function, because words are nice, but if we're in math, functions are better. So if the cost per student is going to equal the $1,200 divided by the number of students, right? Okay. So we know that. That's the first thing. And we don't know how many students are going to attend, but we do know that we want to figure out how many students must attend to make sure that the cost is not more than $7.50 per student. So from here, we're going to look at this and say, okay, first of all, let's find our domain. Because it did ask us, it says, what is the domain of the function? In other words, how many students can attend? Well, we're not going to have a negative number of students. And we cannot have more students than the capacity minus the chaperones. So our domain then is our number of students has got to be greater than or equal to 1, but less than or equal to 312. Okay, so that's the domain. The number of students is going to be between 1 and 312. Because you can't go over 312 because you have a capacity of only 325 people, and you have to have your 13 chaperones. And you can't go less than 1 because negative people can't attend something. Now, to be able to find how much money, or actually how many students we need to have attend this laser tag event, and make it only worth $750, we need to graph this. So we're going to graph two different graphs on the same z and y-axis. Right? So we're going to graph the C equals 1,200 divided by n, or for those of you who like y equals 1,200 over x, it's the same thing. So you're going to graph that as one graph in your graphing calculator. The second graph is you want to make sure you don't go over $7.50. So your second equation is going to be y equals $7.50. So we're going to put both of these graphs on our graphing calculator. Whether you have the 84 or the Inspire, you're going to simply put them both in your graph, in your calculator. So y equals 1,200 over x. If you have the 84, it's a y1, y2. If you have the Inspire, remember put in y equals 12 over x, graph that, then hit Control G to add the second graph onto the first graph, y equals 7.5. You'll notice on neither one of these graphs will they fit in the screen when you first start. So then you need to adjust your window. And I could hit Zoom Fit, but that's still not going to work really well. Because Zoom Fit is just going to keep it with negative numbers, and I don't need a negative number of people attending this event. So I'm going to go into my graph, okay, and I'm going to look at my Windows Zoom, and I'm going to get Windows Settings. And I'm going to let my X minimum be 1, because I'm not going to have less than one student attend. I'm going to let my X maximum be 320, because I know I can't have more than 312, but I want to make sure that 312 is not on the top of my screen so that I can actually read it. So I have a few more things to go over, and you can let it be auto, that's fine. Okay? Or you can pick a scale, you can say go by 10s, go by 20s, go by 30s, go by 50s, whatever. My Y minimum, okay, I'm not going to have less than 0, so I'm just going to put 0, I don't need negative numbers. Okay? My Y maximum is, I need $7.50, so I'm going to go all the way up to $8. Okay? When you do that, it graphs kind of nicely on your screen, and then you get the two graphs, and all you have to do is find the intersection of those two graphs. So then stick in your calculator, do the menu, analyze graph, find the intersection, and when you do that, you will find it intersects at the point of 160 and 7.5. Okay, so you will need 160 students. Okay. 160 students need to attend for it to be $7.50. So there we have that. You put it in our calculator, we've learned how to do it manually, we've learned how to graph with this, and this is reciprocal functions. Reciprocal functions are not all that complicated, they just look a little different than what you're used to. Hit it again. Oh, button.